Broad Street and cases. Map B, it's a modern map of London, and the cases from classical Dr. Snow study, and these cases plotted on the modern map of London. Map C, it's a geoprofile. It's a modern technique previously used in crime analysis in the United States, but now epidemiologists try to use these techniques in epidemiology. And map D, it's a top 1% of geoprofile. And you can see that top 1% of geoprofile near the water pump on Broad Street. So there is a case. This is a case of how the modern techniques support 150 years ago theory. Here I would like to remind you the term of emergent infectious disease, and I would like to emphasize that many emergent infectious diseases are associated with the environment and are strongly influenced by ecological factors such as land use patterns, climate, human alteration to ecosystems. So there are a lot of possibilities for using GIS in the study of emergent infectious diseases. And although it's not very new technique, GIS, but this techniques is on the very early stage. It's a promising technology, and we hope it will have advantages in studying of emergent infectious diseases. In order to establish operational GIS for epidemiological surveillance, we have to follow 3 steps. First step is access digitized base maps. For example, maps of administrative boundaries, rivers, roads, and so on. Sometimes this first step are most difficult because it's hard. Sometimes it's very hard to find the digitized computer file of the territory, of the city, of the country, or some region. Sometimes it's very expensive. Georeference. The second step is georeference epidemiological surveillance data sets. Location and name of site, population data, and so on. And the third step is the choose of appropriate GIS software packages. On the next slides, I will try to explain this scheme. First of all, organizing spatial data. It's another broad figure. The GIS works with the thematic layer of spatial data, and GIS contains information in layers, layers usually contain the similar attributes like layer of streets, layer of districts, layer of rivers, layer of lakes, for example. The crucial is one kind of attribute is one layer. And sometimes there is used onion analogy. Just think of the world like a huge onion. Imagine it. And when we peel the onion, we see the different layers. the same way we can peel the Earth and we generate as many layers as we want. It's impossible to put all the information about the real world into a computer. In any case, we have to abstract real world entities into a computer. And usually, real world entities are abstracted into three basic shapes. It's points, lines, and polygons or areas. Points are used for cases, for retail stores, or wells, something like that. Lines, examples could be streets or rivers or boundaries, and polygons could be districts, countries, houses on large-scale maps. And there is another one, notice. It's crucial to abstract real world into GIS as accurately as we can, because if we abstract the real world not correctly, the results of our analysis will be not accurate. Georeferencing. Georeferencing is the process of establishment of relationships between the data displayed in your GIS software and its real-world location. There is example address of the patients and the georeference on the map. Software. There is a lot of GIS software. Maybe the most popular software, it's possible to find commercial software and non-commercial software. Maybe the most popular software in epidemiologist is Esri ArcGIS. It's used widespread, and you can find the mentioning on it in different articles. It's a very powerful software, but it's very expensive as well. Maybe you have heard about Map-Info, Autodesk Map 2000, and so on. There are several dozens of the commercial software, but it's possible to find non-commercial software. It's free, but it's very powerful as well. For example, GRESS project, it's an open source project. Quantum GIS project, it runs on different operating systems, Mac OS X or Linux or Windows, Microsoft Windows. Maybe you have heard, I'm sure you have heard about epidemiology, a software by CDC. Maybe you have noticed the epimap module. You have seen it? And Health Mapper is GIS software by World Health Organization. Maybe you have heard about it too. And there is another one remark. The abilities, statistical, geospatial statistic abilities of GIS is rather limited. So we have to georeference information, we have to put into statistical software, process it, and then enter it, the process data into GIS to produce thematic labs, to produce cartographic information. Statistical software depends. I have experience of R statistics. There are different geospatial statistics modeling for R statistics, but you can find geospatial statistic analysis in different statistical software. Actually, these software require special knowledge and special skills, and a lot of time, a lot of money. But it's possible to compose maps using GIS, for example, Health for All database. Maybe you know it, yeah? No? It's easy to download it. It's possible to use it on internet or download to your own personal computer and use it offline. There is a database of several hundred indicators, and these database produced thematic tables, graphs, and maps, and there is a map produced in the Health for All database, European Health for All database, HIV incidence in Europe, and I guess some the same maps could decorate your presentation. But it's limited to Europe. On the World Health Organization Global Bureau, you can find a map gallery that contains the extensive list of maps, but it's statical maps. You can edit it. But there is example, death from vector-borne disease in the world. Okay. Geo-statistical analysis. Maybe it's the most sophisticated part, but in the most often epidemiologists satisfied by visual analysis. There is example of severe acute respiratory syndrome in Hong Kong, and the first stage it's plotting all of the cases of diseases on the map, and sometimes visual analysis straightened by exploratory analysis is sufficient for epidemiology. The next step is quantitative model building that require geospatial statistics, and this kind of analysis produce models, and many there is example of model building the same case of severe acute respiratory syndrome in Hong Kong. In spite there are a lot of advantages of GIS, there is a lot of limitations of the application of geographic information systems. First of all, communication gap between epidemiologists and spatial professionals, because GIS software, digitized maps usually are in geography departments, and epidemiologists have not access to GIS. The second, GIS require uniform data standards. For example, epidemiologists try to georeference database, but patients' address could be in different formats. There is example, and sometimes it's difficult to process georeferencing. Third question is privacy issues. High resolution maps could be dangerous for privacy. None of us want to be identified on the maps, or someone